Now in this video we'll be covering torque. Torque is a relatively easy matter, at least I think so. It's a bit confusing but pretty easy to grasp. Now torque is defined by this. It's a kind of a curvy T. I think it was for TOA or TEA. So torque equals force times distance, which can also be seen as newtons times meters. Now I drew a clock, a very odd clock. It looks like the one in that painting. But I drew this because if your motion is going clockwise, it'll be a negative number. And if it's going counterclockwise, it'll be positive. So now let's say you have a force pushing on the hour hand at the 3 of 5 newtons. Now let's say that hand is a pretty big hand, maybe on Big Ben or something, of 10 meters. So you would put 5 newtons times 10 meters, which we have right here. Now this is obviously 50, it's pretty easy. But now let's say, hey, it stopped moving for some reason and you want to find out how much force is acting upon the other side of the clock. So you would put an equation somewhat like this. So it'd be 5 times 10, which is the original torque on the right side, because you're trying to find the net force now, or the net torque. And you would just set it to, so now since that force is pushing up against it, that's going to make it want to go clockwise, that side of the hand. So clockwise is a negative. So it would be 5 times 10, which is from up here, from the right-hand side, minus F, the force that we're trying to find, times 5, which is the distance up there. So basically we're combining these two sides with this equation. Now this will be, so you would add 5, it's equals to 0. So you would combine them, and then you would add 5F to both sides to get rid of it and isolate the variable. And then you would divide by 5 on both sides to give you 10 newtons equals the force you're pushing. So now this helps identify leverage. So whenever you're trying to lift an object, so let's say I'm trying to lift this tray here with this comb. Hold on. Now, let's say the closer I get, it'll be harder to pull. So the closer I get, it'll be harder to push up. But the further back I get, it's a lot easier. That's because there's more of a distance to cover than the amount of force I have to put, which is this. So, yeah, that is our torque coverage. I hope you understand that.